Okay, this is about the quadratic functions. Now, first of all, let me discuss a couple of homework problems. Okay, the one of the homework problems I want to discuss. Let me discuss the homework problems first. One of the homework problems I want to discuss is number 10. Okay, from the homework probabilities. Okay, so this is a problem we did it before. So okay, let's see. Let me describe the problem. Okay, the problem says that Miranda will flip a coin 6 times. What is the probability that 2/3 or more of the flips will be hit? Express your answer as a decimal to the nearest 1,000. Okay, this is a problem. Please remove this check mark on the screen, and somebody is always very naughty to do that. Okay. All right. So this is so Miranda. Who is Miranda? Miranda last name is called Song. Okay. She was one of my students. She went to Harvard University a few years ago, and she was also one of the few best high school students at Common High School. Okay. So Miranda will flip a coin 6 times. Okay. So what is the probability? Let's do this problem. Okay. What is the probability that 2 over 3 or more flips will be hit? Okay. Okay, so to solve this problem, we are going to use multiplication, product rule, and more important, addition rule. Okay, so 2 over 3 times 6 is going to be 4. So in other words, you're going to get at least four of the flips will be hit. Okay, so what you should do is this kind of event consists of several events. They are not showing up at the same time. So that you want to find the probability you get exactly 4 of the flips will be hit. And you want to get a probability for exactly 5 of the flips will be hit. And as long as you know how to solve the problem like that, then you add them together, you get the answers. So my question is, we want to find out the probability that exactly K of the flips, okay, K could be 2, could be 3, could be 5, will be hit. Okay. Now, how to solve this problem? You because Miranda flips a coin 6 times, so each time, okay, you only have 2 options, right? 1 or 2, H and T, right? H means the heads, T means tails. Okay, so if you want to get that probability, I'm going to call it PK. Okay, so that probability, the denominator will be 2 to the power 6. Okay, 2 to the power 6. Okay, but for the numerator, you want to get exactly K flips hit. So that means K could be, K could be 1, could be 0, 1, 2, all the way to 6. 0 means no of the flips will be hit. Okay, so let's assume, for example, K equals 2 or 3, right? So that means you label these places like 1, 2, 3, 4, 5, 6. Okay, and you view them as a student with name 1, 2, 3, 4, 5, 6. You are going to call 4 of the students, okay, to form a committee. If those students are called, for example, number 2 or number 4, number 6, number 5, if those 4 students are called, then you give them H, okay? You give them an H, that means, corresponding to the coin which is headed, okay? So how many possible outcomes, design outcomes in this case? It's actually you select 4 out of 6 students to form a committee. So order doesn't matter here, okay? Really the order doesn't matter, okay? Because 2 means in the second position. Sounds like the order is counted. Like you think about the order actually is not counted because it's used second. The second position, second place is named 2. It's actually like a person with a name 2. So you call those 4 people, then you get, we put the H over there. Okay. So it's actually you just needed to select K members from a group of 6. Okay. And that's the same as this. So if you think, if we can figure out the numerator, then you solve the problem. Now you want to get the probability that at least 4 of the flips will be hit. So you can have exactly 4, exactly 5, exactly 6. So total, the answer will be P4 plus P5 and then P6. And this is all of them has the same denominator, 2 to the 6. So the first one with 6 factorial, 4 factorial, 2 factorial, and then 6 factorial, 5 factorial, 1 factorial, then 6 factorial, 6 factorial, 0 factorial. Actually, the last one is 1. Then you add them together, you will get the answer. Okay, so the answer will be the answer will be 2 to the 6, and the first one is 5 times 6 divided by 2, and this will be 6 plus 1. Okay, so what you get is 15, 6, yeah. 15 plus 6 plus 1. Let's double check it again. 16 plus 6 is going to be 16 plus 6 is going to be 16 plus 6 is 22. Okay, and 2 to the power 6, and finally you get 11 over 32 after simplifying. Okay, I think the most important part is how to count the possible outcomes. The design outcomes have exactly 4 hits. Okay, and this is equivalent to select 4 people out of group of 6 to form a committee. Okay, if you realize that, then you will get a correct answers. Okay, so that means the first place you can, if you use the first place as 1 person can name the 1. Second place, is viewed as a person number 2, right? Whenever that person's name is called, then you put H there. And I think for the this is the same as that's like a same as selecting 4 people out of 6 to form a committee problem. Okay. The next problem, we have to use a product rule. Okay, this is a problem number 13. Problem number 13, 3 girls are each given 2 standard dice. Each of the girls rolls her pair of dice and write down the product of the 2 numbers that she rolled. What is the probability that all the girls have written down a product greater than 12? Now, all of the girls, actually, this is just three girls, right? The first girl, second girl, and third girl. And I think all you needed to find the probability that 1 girl, get product of 12, or product greater than 12. Yeah. So this is a question actually, we just need to find out what is the probability that, okay, has written down a product, okay, of a product greater than 12. Okay, if it rolls, yeah, if she rolls her pairs of dice, okay. So I'm not going to write down the whole problem. So if you're able to find this problem just for one go, okay, then you solve the problem. So you get two numbers. When she rolls a pair of dice, right, you can count the order, you know, one by one. That's fine. It's the same result, right? One by one. Let's do this, okay? So the probability is the denominator will be the first one gave, you know, you have 6 possible numbers. You get 6, right? So 6 times 6, that's the denominator. Then you want to get a pair of numbers, the product is greater than 12. What kind of numbers you can product terms, right? So 3 times 5, 3 times 6, 3 times 4, yes, it's less than 2, that equals 12, not greater than 12. Then you look at 4, 4 times 4, 4 times 5, and 4 times 6. Then you look at 5, 5 actually starts from 3, 5 times 4, 5 times 5, 5 times 6. Then you look at 6, 6 times 3, 6 times 4, 6 times 5, 6 times 6. Those are all the desired outcomes. You know, you will get product greater than 12. Okay, so that is going to be, you just count all of them. It's a 13. Okay, so that means for one girl, if she rolls a pair of dice, okay, and there's a probability to get product greater than 12 is going to be 13 over 36. Okay, and those 3 girls are doing the same thing. That's right. Then you want to get one by one each girl, right? You want to get the same product greater than 6. What is the probability? That's just a sequence of events, one followed by another one, and you want them all appears, right? You want them all appear. That means the product, the probability for 3 girls all get product greater than 12 is going to be p cubed, right? P times 3, p times p times p. That's a product, and that is going to be 13 over 36 cubed. Okay. Then after you multiply them out, that is answer in the answer key. It's very similar to the problem like on Monday is a chance to get rain is 10%. On Tuesday the chance to get rain is also 10%. And what is the probability that what is the probability that on 2 of the day every day is going to rain? Okay, so then Monday, Wednesday, right? Monday, Tuesday, then just the product of those 2 probabilities. Okay, so this is, you have to use the product rule to solve the problem. For the last problem, I suggest you to look at the examples, exactly the same examples. I only change the numbers, and you should look at my notes. Okay, I did not discuss in the class. You have to understand what they mean. What does it mean? The best of 5 games. Okay, if you understand the best of 5 games, and you can solve the last problem. The last problem says that a best of 5 series ends with one team wins the 3 games. If some team wins the 3 games, then this game is over. Okay, so so why just best of 5? Because when they compete with each other for 6 times, at least one of the team will win the, you know, I think stop with 5, okay? Because at the 5, right, at least one of the 3 will win the game, right? For example, their possibility, and the first case is like, let me write down the answers, okay? So that problem 15. So there are several patterns you're going to get. The first pattern is only 3 that compute 3 times, then end. Okay, so 3 times. So either AAA or BBB, right? So A means the team A wins, second, third time, first time, second time, third time, then game is over. Or the BB, right? If the mixture, then you have need more terms, right? More times, right? So if there 4, then you have A, B, A, that will be A. So the first time the team A wins, the second time team B wins, and then team A wins, team A wins. So there is a possibility, right? So, and it's possible if you just look at this, all the possible cases, the team A wins, and then you're going to have A, B, A, then I think that's it. You cannot say A, because when A, then that's already done, because the team A wins the first time, second time, third time, there's no chance for the B. Okay, so that is this is the idea. So the example is already clearly explained to you. Okay, and yeah. So and then there's a possibility the team B wins twice, but still the team A wins. Then the this will be now considered, and the possible pattern will be the team B wins twice, second times, then after that the team A wins. So there's a 2. Let's write down all the possible patterns. Okay, and you're going to have a 6 total. Okay, A, B, A, B, A, then A, B, B. Okay, so those are all the possible patterns, and that's it. Then you can't use a product rule along each line. Use a product rule along each line to get the probability. So the team A wins first time, second time, third time. What is the probability, right? Then team A wins 1 time, and 3 times. The team B wins 1 time, and then you look at the probability for each of them. So actually, you have so many cases: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have 10 cases. In each case, you figured out the probability. Then add them together. Okay. Then add them together. Okay. So for the exercise, you know that the team A, the probability for team A wins the competition, wins the So let's see. So defeating team A. The probability of team A defeating team B in any of the game is 3 over 4. So team A is stronger. Okay. That's okay. Okay. Then the first case is going to be when that happens is going to be the first case is 3 over 4. Okay. Now the second case is 3 over 4. Team B has to win 1 over 4, 3 over 4, 3 over 4. The order doesn't matter. Actually, you have how many? 1, 2, 3. So you put 3 here. And you have 6 here. 1, 2, 3, 4, 5, 6. And each of them here 3 over 4, 3 times. And 1 over 4 square. So add them together. That gives the answer. Okay. So here for each case, you use a product rule for the probability. Then you have 10 different patterns here. Then use a addition rule to add them together. Okay. So when you do the problem, just look at the notes. Maybe I already have exact same problem. I just wanted to understand it. Okay. You look at the example, then you should be able to solve. All right. Now today, let me focus on the last topic. Okay. This is about quadratic function. Now we already studied linear functions. We studied quadratic functions a little bit. A quadratic function means a function, function, then the expression written in the form x squared plus bx plus c. Okay, and here is not going to be 0, otherwise it's called a linear function. A function which is described by a quadratic expression is called a quadratic function. Okay, and for the quadratic function, first thing we can talk about is the graph. Okay, the graph. The graph of f is the graph of the equation. Now there is a difference between equation and a function. Equation means you have two variables, okay? And those two variables are related. So what does it mean, a graph? A graph means this is x-axis, y-axis. When you choose a value for x and you calculate the y value, and then you get a point. So when x changes, the y value changes, but how does the y value change? Y value is determined by the three terms. So you end up with a graph so-called a parabola. Okay, it must look like that. Then when you look at the parabola, you find out there is a lowest point in some cases, in the case a greater than 0. So how do you find the lowest point? Okay, and the lowest point is going to be called h and k. How do you get the h and k? Well, you needed to express this function in a different form, and that different form is x minus h squared plus k. Okay, if you're able to express it in this form, then you get the coordinates of the vertex of the parabola. Okay, so let's write down a specific. Let's look at a specific function to see if we are able to figure out those if I'm able to figure out this. Okay, so let's see. So take a look at, here's a function. Okay, this is x squared minus 4x plus 3. All right. All right. I know this looks like a parabola. Okay. The graph, right? It's a quadratic function, and I know the parabola opens upward. I do want to know the vertex. Okay, the vertex. So how can I express it in the form a is going to be 1 here? How can I do this? How can I express in h and k? Okay, so think about that. If we can express in this form, that means h and the 2h, right? So that means from this formula, you want to compare the coefficients. You find out h clearly is going to be 2, right? 2 times 2 get 4x. Then h squared plus k equals 3. So I can figure out 3. I figured out k because k equals 2. The h is equal to 2, and k is going to be 3 minus 2 squared, which is -1. Okay. So in other words, my function is going to get x minus 2 squared plus minus 1. All right. Now, this is how do I get the vertex information. This is a 3, right? 3, okay. So how does the graph look like? H is going to be 2 and the -1. Okay, 2, -1. Okay, the parabola opens upward. Okay. Okay. So you get a graph, and you get a the standard form. Now, why those coefficients 2 and -1 is going to be the vertex? Think about that. This function, x minus 2 squared, right? The first part is non-negative. It's never be smaller than -1. So it's always greater than or equal to -1. Right? It's greater than or equal to -1. Right? From here, right? Because this part is negative. So the lowest value for the function is going to be 1. And the f of x is going to be -1 when x equals 2, right? When x equals 2, this term is 0. So 0 minus -1 is going to be negative. So the smallest value will be -1. It occurs at the 2. Okay? So we can say that the minimum value of f is going to be -1. We can say that which occurs at x equals 2. Okay, and it's easy to see that from the expression, the standard expression for the function, but it's not easy to see that from the original version of the like x squared minus 4x plus 3. Now, but you also see that there's 3 intersection points here, right? 3 intersection points. Those are called the roots. Okay, the roots of f. Okay, actually those are intersection points on the x-axis between the graph and the x-axis. How can we find it? We can find it in a couple of different ways. First of all, if you already know, if you already know the standard expression, then you just need to solve this equation. So there are a couple ways to solve the equation. That means x squared minus 4x plus 3 equals 0. But we also have this equals 0. I think the second one is better to solve it. Does not mean that you cannot solve the first one. Okay. For the second one, I can move -1 over to the right side. Okay. Then x minus 2, something square equals 1, then that must be plus minus 1. So right, x minus 2 squared equals 1. X minus 2 must be either 1 or -1. So it's 2 plus minus 1. And when it's addition, it's 3. When it's minus, it's 1. Right, so you get 2 possible x-intercepts. You get 2 x-intercepts. Okay, so those are called also called the roots and also called the x-intercepts of the graph. Right, but from here, if you haven't changed the form of the quadratic function into the standard form, now how do you solve this question? There are a couple ways to do it. One is trying to factor it. And you can say x squared minus 4x plus 3 supposed to be x. Okay, x you can do like this, x minus, let's choose a positive. Okay, it doesn't matter. So that means that means n plus m should be -4, and m should be equal to 3. I think n m must be both negative. Okay, otherwise, at least one of them should be negative. Otherwise, the sum is not going to be -4. But if one is negative, other one is positive, then the product will be negative. So both must be negative, and it turns out to be n is going to be -3, m is going to be -1, or switch the order. Right. So now you get x squared minus 4x plus 3 equals x minus 3, x minus 1. Okay. Now, if you can, this is called a factoring. If you can factor it, then if you set this to be 0, then x minus 0 should be 0, or x minus 1 should be 0. So you get 2 solutions. Either x equals 3 or x equals 1. Okay, the last method we can use is quadratic formula. Okay. So that's all kind of problems we need to learn. Okay. Now, if you already know -3 is, if you know 3 is going to be 3 is going to be a solution, then 3 is going to be root. Then if you plug a 3 for the x, you should get 0. Okay. Yeah. F of 3 is going to be 3 squared minus 4 times 3 plus 3. This must be 0. F of 1 is 1 squared minus 4 times 1 plus 3 is also equal to 0. That indeed as a solution. All right. All right. So let me summarize about the roots and factors. All right. A root, okay, I is called a root of this function. Okay. If f of I is going to be 0, just a 0. Okay. Okay. Now if that's the first point about factors. If f of x can be written in the form and here is px plus q, then mx plus n and px plus q are called the factors of the f. This is called linear factors. Sometimes not all the functions can be written in that form. And here's the example. If f of x equals x squared minus 4x plus 3, okay, then we know that this is going to be x plus minus 3, x minus 1. Okay, so each of them is a factor. So x minus 3 is a factor of f of x. Right? And I guarantee if it's written in this form, f of 3 is going to be 3 minus 3, 3 minus 1 is going to be 0. And f of 1 is 1 minus 3, 1 minus 1 is also 0. Now, how do you get x minus 1? You can also use a long division to get. If you know one of the factors, you can get the other one. There are a couple ways to get that one. Okay, if x minus 3 is a factor of f of x, can we get the other one? We can get it using the following long division. Okay, okay, and what I'm going to do is you're going to differentiate x squared minus 4x plus 3 by, you divide x squared minus 4x plus 3 by x minus 3. That's called the long division for polynomials, okay? All right, so you get, first of all, you get an x. So you get x squared minus 3x. And take the difference, subtract. X squared minus 3x from the above, x squared minus 4x plus 3. So negative 4 minus negative 3x would be negative x. Okay? then you have to put -1 here. So negative x plus 3, and you take the difference, that's going to be 0. So its quotient is x minus 1. So therefore x is going to be x minus 3, in fact, and plus 0. The remainder is 0. All right. So this is about polynomial. All right, so let's see. The first problem is to verify that 2x plus 1 is a factor of f of x. The leading coefficient is 2. Okay, how do you verify it? How do you check? Now, there are many ways to show that, okay? For example, the most stupid way is by definition, of course, true. So you know f of x is going to be this factor, right? And the other factor may be px plus q. Now, if you're able to find pq, then you're done, right? Okay? You can do this, okay? So we're trying to find the other factor, if possible. Now, how do you find the other factor? You can use a long division, or you can multiply them out, compare the coefficient. Okay, that's doing 2px squared and the 2qx plus px plus q. And you compare both sides, and you will see that, oh, 2 should be equal to p, -5 should be equal to 2q plus p, and then this is a -3, right? -3 is going to be q. Now, can you find the pq quickly? No problem. You already know q, you already know p, then p is going to be 1, q is going to be -3. Okay? You can double check whether this is the minimum hold. And 2 times, wait a minute, let me try to figure it out. All right. Yes, this is -3. Yeah, q is -3, so 2 times -3 plus 1 is going to be -5. Yes. So we will get x squared minus 5x plus 3 equals 2x plus 1 and x minus 3. Okay. So now you prove that this is indeed a fact, but does not mean this is a unique way to do it. Another one is this called determines the coefficients, right? Another way you can get is get as a fact to prove this is indeed a fact. You have to prove that this quadratic function is divisible by 2x plus 1. Now let's see if we get what kind of remainder we get when you divide. So you get 2x squared, x, 2x times x squared plus x, then do subtraction, -6x minus 3. I think -3, -3x minus 3, so the remainder is 0. Okay, so that means f of x, 2x minus 5x minus 3 is going to be 2x plus 1, x minus 3. Okay, this is another way to get all the factors. Now, this is the second method, right? There's another method to show 2x plus 1 is a root. Okay. Okay. So f of x, take a look at, right? So that means, okay, 2x plus 1 is a fact of f if and only if x equals -1/2 is a root. Do you agree? Yeah. Okay. Right. Okay, so all you have to do is just check. You solve, you set that factor to be 0, so you get the root of that factor. That root should be the root also for the polynomial. Yeah. Right. So as long as you verify x equals -1/2 is a root, then you solve the problem. But this is not the best way to do, because even you show x equals -2 is a root, does not mean you already get all the factors. Okay. So let's check. F -1/2 is 2 times -1/2 squared minus 5 to the -1/2 plus minus 3. So it's going to be 2/4 is 1/2 plus 5/2 minus 3. And that's clearly is going to be 0. Okay, so that implies x equals -1/2 is a root of f. Okay. All right, I'm going to ask you to try this. For what the value of k is x plus 1 a factor of x squared minus 3kx plus 2. So you have to determine the variable k, so the x plus 2, which is already pre-given, should be the fact. You know, sometimes you have to make a problem, right? Make up this problem. So the x plus 1 is a factor. And to do that, you needed to modify the coefficients. So here's a question: what kind of coefficient you can have so that it is going to be x plus 1 is going to be fact. Okay, please show me how to do that. I give you a minute to work on that. Okay. Yeah, to determine what value is going to be, I think the easiest way for this problem is to use the last method I showed you. So x plus 1 is a fact. If and only if x equals -1 is a root. Okay, so use the root, then you just need to say 1, -1 squared minus 3k times -1 plus 2 should be 0, right? Plug -1 for x into the formula. So it's 1 plus 3k plus 2 is 0. So k is going to be -1. Okay. Otherwise, how do you do that? Well, this is not a unique way to do. Okay. So where's my file? And it's gone. So I'm going to bring up. Yeah, let's minimize it. All right. Yeah. All right. So there's another way you can do it. Just go ahead to pretend that your x plus 1 is a fact, and you try to divide the x squared minus 3kx plus 2. You should get a remainder. The remainder should be 0. Then you end up with k equals -1. Okay. Yeah. So this is the first method. The second method, they just go ahead. Nope. What happens? My file is gone. Okay. Yeah, it's weird. Okay. I'm going to be careful when I write it. So it's -3x plus 2. You divide x plus 1. So first thing is x. It's fine. X squared plus x. Then you do subtraction, 3kx and minus x plus 2. And this is trouble here, right? So you want to get rid of this. I think you have to minus 3k minus 1. You have to do this part. And then you get 3k minus 1 times x plus minus 3k minus 1. So now if you do subtraction, you will get 2 plus 1 plus 3k. So this is the remainder. This is supposed to be 0. Then clearly k equals -1 again. So it's the same result, but a little bit complicated. Okay. All right. Now, how many of you know how do we get the quadratic formula? Remember the quadratic formula, okay? X squared plus bx plus c equals 0. So what happens to my screen? You cannot see it? All right, I needed to. So I still should screw down. You want to, what do you want? You want to look at this again? All right, this is a problem we want to find. Okay. Now we have to move on to the next problem. Okay, and if you just given a quadratic function, okay, if just read the quadratic function, I don't know what's happening. The screen is not moving. Okay, hold on. No, I'm sharing. It's okay now, right? Yes. Yeah, okay. So if you're given this quadratic function, there's a formula. It's called the quadratic formula. So the roots are given by the formula, and you have a 1 and a 2 roots, okay, and depends on sign 2a here, -b plus minus b squared minus 4ac. Okay, now we got this. I hope you know how do we get this. Okay, we got this using the following idea. First of all, you x squared plus bx. I put -c to the other side, right? Then I divide both sides by 8. Okay. Then I'm trying to complete square on this side. How can I complete square? I have to add half of a over b squared. Okay. Why have to add half of a over b squared? Because when you when you square it, the middle term will be double of x times b over 2a. That's the reason I need a 2a here. Okay, so that, and on the right-hand side, this is a b squared 4a squared. Can we put together, combine them into one terms? I think we can do that. So you end up with b squared minus 4ac. Believe it or not, okay? This is where it's from, b squared minus 4ac. So then the solution, the real root is going to be plus minus b squared minus 4ac divided by 4a squared, okay? And then you can also write as, okay? So this is how do we get the quadratic formula. If you move b over 2a to the right-hand side, that's what you got, okay? All right, and then you can use that to get the standard form also. Yeah. So let's look at this following problem. Okay. I'm going to express negative 2x squared plus 4x minus plus 2 in the standard form, okay? And ax minus h squared plus k. Now, how do you solve this problem? I'm going to show you the different ways to solve the problem, okay? Then the direct way to do, just like what we did for the quadratic formula. So you take negative 2 out, okay? And then write this. And you try to complete the square. So what term I'm going to add here? I think I'm going to add 1. But when you add the 1, you have to minus 1, okay? Then you will get x minus 1 squared minus 1. Then you simplify it. Negative 2 times negative 1 is plus 2. And that's why you get 2. Here 2 plus 2 is 4, okay? So this is a good part. Now, if you are able to express it in this form, then what you can get from that, you will get the following information. First of all, this term never be positive, right? So it's always less than or equal to 0 plus 4. So, and then you also see that when x equals 1, you get negative 1 minus 1 squared plus 4, it's 4. So 4 is the maximum value of the f of x. So there's no value larger than that f can reach. So f of x, no matter what's for what value x, it's always less than or equal to 4. Now, when you draw the graph, okay, so graph is given y equals negative 2x minus 1 squared plus 4. So the largest possible value for y is going to be 4. Where it occurs, it's 1, 1, 2, 3, 4, 1, 4. So everywhere else, the y value is going to be smaller than 4. It's below that. So actually you get a parabola opens downward, and this is a vertex. Okay, it's a vertex. So you can see that, right? So this is the arbitrary point, x and the y, and the y is determined by this expression. It's always less than 4. So that point on the parabola is always below that vertex. Okay. Now, if you now can you find once you have a standard form, it's easy to find the roots, right? To find the roots, we just needed to, we're going to find the roots, okay? Then you just needed to set, using the standard form, it's easy to find the roots, okay? And then you x minus 1 square equals 2, right? So x minus 1 equals plus minus square root 2. So x is 1 plus minus square root 2. So you get 2 roots. They're not integers. But you can also use the quadratic formula to find the roots. Because if you have 2x squared plus 4x minus 2 equals 0, suppose you're not given the standard form, then what is the best way to do? If you want to find the standard form, it's fine. If you don't have it, you don't want to find it, you still can find the roots using the quadratic formula, okay? Negative a in the denominator, 2a, 2a in the denominator, 2 times negative 2, negative b plus minus b squared minus 4ac, okay? So we can simplify it, let's see. We get negative 4 plus minus 4 squared, and what do we get here? Negative 4, negative 2, part 2, so actually it's 4 squared. You have double 4 squared. So you get square root of 2 times 4 squared. So I can take a 4 squared out. So I get negative 4 plus minus 4 square root 2, right? Then negative 4 divided by negative 4 is 1. Negative 4 divided by negative 4 is positive 1. So actually it's still plus minus square root 2. Okay, so that's why you get the same answer, but use a quadratic formula. Quadratic formula guarantee you will get an answer, but sometimes computation is complicated. Right? And okay, now when you try to one more thing, when you try to factor, quadratic function, you can also use the roots to factor it, okay? Because if R1, R2 are the roots of a quadratic function, okay, f of x equals ax squared plus bx plus c, then this function must be written as x minus r1, x minus r2, okay? And then this is the same as here. Okay, so for our above problem here, negative 2x squared plus 4x plus 2, so when f of x equals negative 2x squared plus 4x plus 2, since you already know the 2 roots, you can take 2 out. And x minus the first one, 1 plus square root 2. Second, 1 minus square root 2. Wow, but those are not a nice number, they're not integer. That's fine. You can still factor a polynomial, a quadratic function, as a product of two linear terms. So coefficients are real numbers. Those are the real numbers, but not necessarily integers. This can be real numbers. Okay. So now we've gone through all kinds of things: factors, roots, quadratic formulas, factoring, graphs. That's all we learned today. I was a little bit hurried because because we don't have I discussed the probability problems at the very beginning, okay? And I need I want to spend 1 more minute to discuss the following problem. Find the value of m such that x squared plus n x minus 2x plus 16 is the square of a linear expression. Now, what does that mean? So that means this is going to be a linear expression like that. Right? This is my function. But originally it's x squared minus plus m minus 2x plus 16. Now you want to express in that form. What does that mean? That form, if the function is written in that form, the square of a linear expression. This means it has only one root, okay? So it has only one root. When it has only one root, if you look at the quadratic formula, only when b squared minus 4ac is 0 in the quadratic formula, okay? So what is my b? B is m minus 2, 4, a is 1, c is 16, okay? It's going to be 0, right? So look at that, b is from here. So that means m minus 2 is 4 times 16 square. So m minus 2 is going to be 2 plus minus 2 times 4, which is plus minus 8. So m is going to be 2 plus minus 8. You're going to have two solutions. When it's choose positive, you get 10. When you choose negative, negative 6. So, so that's all the problems I discussed. I will send you the notes. In the notes, they have a couple more examples. And when you do the homework, you go through the examples first, then you do the homework problem. Otherwise, you know, maybe if you see the examples, you can quickly solve the problem. Just like the last problem, number 15.